Not every two-dimensional figure that we might want to find the area of is going to be made cleanly of only one type of object that we've seen so far. So what this video is going to do is going to give you a chance to practice finding what we call compound or complex area. That is when we have to use multiple area formulas or we have to break down figures in different ways to find the area that we want. So one example of a slightly unusual figure would be this sort of U-shaped thing here. We know that in this case, any of the lines that appear to be perpendicular are perpendicular, and that's going to help us with the area formulas. So go ahead, pause the video, see what you can do about finding the area of this figure here. We're looking for everything that's enclosed within the figure. Come back when you're ready to see one potential way to do it and move on. So this particular figure is actually rather nice because it's just made up of rectangles. We can cut them up in any way that we want, but the most straightforward way is to not move that line there, but rather to just cut it here. And so we have two rectangles that are the same. This is 44 centimeters squared because that's 4 times 11, and 44 centimeters squared because that's 4 times 11. And if the length from the top rectangle down to the bottom of that rectangle is 11, and the total side is 14, well then this is 3 centimeters remaining there, 14 broken down to 11 and 3. So 18 times 3 is 54. And now we have 44 plus 44 is 88 plus 54 is 142 square centimeters. Now let's look at a slightly different example. Here we have a circle nestled into a rectangle and we want to find the area that is shaded. Now what we need to know here is that the circle is tangent to the rectangle on 3 of its sides, and that's going to allow us to find some other critical measurements. So go ahead, pause the video, see what you can do about this one by taking the area of the rectangle and the area of the circle and putting them together in some way, shape, or form so you're left just with the oddly shaped shaded area there. So here we could talk about the exact area of that circle, but because the area of a rectangle doesn't involve pi, it's not going to be particularly helpful. So the area of that circle is pi r squared, or 3.14 times 9, because 3 squared is 9, and that gives us a total of 28.26 square inches for the circle. Now, if 3 inches is the radius of the circle, then extending that from the radius to the diameter gives us a total of 6 inches for the diameter, which also then happens to be the length of the side of the rectangle, because if that radius is connected to the tangent side of the rectangle, it is perpendicular, so that whole diameter is perpendicular to the two sides of the rectangle, which makes it the width. So 8 times 6 is 48. So the entire rectangle has an area of 48. The circle has an area of 28.26, and the circle is the only part of that that is not shaded in. So if we take the total area of the rectangle being 48 and subtract 28.26 from it, we end up with an area for the shaded region of 19.74 square inches. So if we have a shaded area, that means we can take the totality of the figure and subtract out the things that are not shaded, which is exactly what we're going to do in this last figure. So this is a circle that is inscribed in a square that is inscribed in a larger circle, and we want to find the area of the 4 shaded figures there in total. So go ahead, pause the video, do what you can to find the area of those shaded sections, come back when you are ready to move on. Well, as you notice, the inner circle isn't actually shaded either, and it's there not so we can find the area of it, but so we can find the dimensions of the square and therefore of the circle. So since that inner circle has a radius of 1 inch and it's inscribed in the circle, that means the 2-inch diameter is the length of a side, and that means that the area of the square is 2 squared, or 4 square inches, as the area of the square. Now that radius is going to then help us find the radius of the larger circle, because if 2 inches is the side of the circle, we can calculate the diagonal of a circle. Let's try to get a slightly different color there. We can calculate the diameter of the square of the circle by finding the diagonal of the square. And the square splits up into two 45, 45, 90 triangles. So this is 2 and 2, and then 2 root 2, because that's the hypotenuse, which means that the radius of that circle is half of that, so the radius is square root of 2. And in the area formula of pi r squared, that is square root of 2 squared times 3.14, square root of 2 squared, of course, is 2, and 2 times 3.14 is 6.28 square inches. That is the entire circle. Take away the square to get a shaded area of 2.28 square inches. So 3 examples of more complex area that you can find using the area formulas that we've seen before, either breaking it up into smaller figures that we know how to find the area of, or in the case of shaded area, find the area of the largest figure there that contains all of the shading and subtract away the polygons or the circles or the other figures that you know the area of that do not contribute to the shading. So if you've taken the entire thing minus what's not shaded, you will be left with what is shaded.